change in your dependent variable can be explained by these predictors. So a predictor is not to say that it is the cause, just saying, well, this seems likely that these things may influence this outcome. So a predictor can be a cause, but not always. So this will most probably help you a bit more. So when you have research questions that are descriptive in nature, you ask the question, what? What is it? What does it look like? So you describe the characteristics or identify the characteristics. You describe relationships and you describe differences. When your research question is explanation, you ask questions of why and how. Then you explain the relationship and you explain the outcome. If your research question is prediction, then you ask the question, when is this going to happen? Then you predict relationships and you predict outcomes. If your research question is about intervention, then the question is impact. Did it work? Did it change something? Describe, explain, predict, intervene. Any questions so far? Now this is just, I think, a nice way to try and understand quantitative methodology and trying to figure out how do we control, meaning how do we try and be as objective as possible when we study something, but also taking into consideration that there are certain things that we need to have in place to make sure that the conclusions that we are drawing are based on accurate information. So we've got the cause construct and the effect construct. So this is your dependent variable. This is your independent variable. In quantitative research, more often than not, we would like to know, is there a relationship between those two? If you had cats, they would go wild. Okay, I'll explain it later. So is there a correlation between the two? But before you can determine that correlation, you need to look at your operational definition, meaning how do I measure my independent variable? How do I measure my independent variable? You may say, well, that sounds straightforward. But if you've got a measuring instrument that is not reliable or that is not appropriate, you will have a tough time determining the strength of that relationship. So let's say, for example, you want to measure self-efficacy, but you use an inappropriate measure of self-efficacy, and you would like to determine the relation between self-efficacy and resilience. And in your study, you don't pick up a correlation between self-efficacy and resilience, but the theory seems to suggest that there is such a relationship. Now you have to explain, but why did you not get such a correlation in your study? And then the question will be asked, but how did you measure self-efficacy? How did you measure resilience? And if there's a problem with your measure on this side, then it creates some marked psychological distress in your study. Okay. So on this particular point, please make sure that when you choose measuring instruments, use measuring instruments that will provide you with reliable information that seems to be accurate measures of the construct that you would like to measure. Where do you find them? If you go through your literature review for your study, you will more often than not find that most researchers will publish the questionnaires that they've used with the information on the reliability as well as its validity. You can use it. It's a completely different ballgame the moment when you want to create your own research instrument. Then you need to establish the psychometric properties of your instruments beforehand. bear in mind whether or not you're going to observe a relationship between the variables will more often than not be influenced by the quality of your measuring instrument. So that's the first thing. Bear in mind, when you measure your dependent and independent variable, and you observe correlation, then you need to look at theory and say, but why is there such a relationship? Can this relationship be explained by something else? Are there other predictors as well? Are there other variables as well? For this, more important to think about, am I measuring my variables using appropriate measuring instruments? If that is so, then you should have no real problems in terms of observing any correlations. There is such a thing called construct validity. Not to go in too much detail, but the main idea with construct validity is to ensure that your instrument is measuring what it is supposed to be measuring and nothing else. There's also such a thing called as external validity. Anyone willing to take a chance? What is meant by external validity? Don't worry, I will explain. Is the power on there?
Is there some factor that has a direct effect on your external factor that has an effect on
Okay.
specific?
Close. Yeah. So when we think about, well, some factors external that influence it, that's true. Usually when we think about external validity is to say, well, to what extent can we generalize what we observe here to something outside of this study? There's another term, internal validity. That's closer to what you were saying, to say, but to what extent is this relationship explained only by this variable, or is there something outside that can explain that? So let's have a look. So now that you've got a general idea of your research questions, describe, explain, predict, and intervene, let's just have a look at general research designs. So we will look at the research strategy, some of the settings, main definitions, and choosing your sample. So your main research strategies that you can use will be experimentation. You can use surveys, you can use qualitative designs, or you can use evaluation research, which can be a combination of various techniques. More often than not, while in the social sciences and economic and management sciences, you usually don't do experimentation. Though I always wonder and figure out whether or not that shot will work for that student or not. Okay. So experimentation is not always possible, but surveys, yes, where you administer, where you take your questionnaires, you administer it to a large group of individuals, get the results back, analyze it, and do the data analysis. Can't say much about qualitative designs, but evaluation research is all about impact. Did that intervention work? And for evaluation research, you need to have some kind of experiment or quasi-experiment, the pre-test, post-test techniques. I will not go into detail about these designs, but you will find in any good research methodology textbook, well, what are the advantages associated with a survey? What are the advantages associated with experimentation? I'll just give you broad characteristics associated with each. So, a true experimental research design, as I've said earlier, you've got your pre-test and a post-test, control group and an experimental group, and random assignment. Not always practical. An example, if I want to determine the impact of safety training in an organization, I will find it very hard to convince the organization to send some employees on safety training and the others to stay as they are and create havoc in the organization. So it may be theoretically possible, but not very practical. Then we've got quasi-experimental research designs. So a quasi-experimental research design is not a true experimental research design. Usually what happens is there's no random assignment of individuals to either control group or experimental group. And then we've got some different variants there as well. But if you can't use the true experimental research design, and you still want to at least get close to cause and effect, try quasi-experimental research design. And then we've got non-experiments, where we don't manipulate any of the, let's say for example, interventions. We just take one measure at a single point in time. It can be longitudinal as well, but there's no intervention, and you just see how things happen. So non-experimental research designs usually surveys to some extent. The joke about quasi-experimental research designs. How many of you have seen the Austin Powers movies? Where Dr. Evil told his son, but you are the quasi of evil, the Diet Pepsi of evil, not the real thing. Okay, so quasi-experimental research design is not the real thing. So that's in terms of research designs. Yes, the one that you are more or most likely to use in quantitative research will be a survey research design, where you hand out questionnaires to a large group of individuals and you get their responses on various topics. Usually those questionnaires are of a standardized nature, so you ask the same questions to all the individuals in that particular survey. You try and get large enough sample to try and get as representative response as possible. And we also focus on using questionnaires with reliable and valid information. Okay, so just in terms of sampling, there are two approaches to sampling. You can either go the probability sampling or non-probability sampling. I don't think I've got the rhythm. In any case, so just like in research design where you've got the true experimental research designs and quasi-experimental research designs, with sampling you get something that is theoretically very useful but not always practical. So although you may think that you will go for simple random sampling or using probability-based sampling techniques, that may not always be possible. Then you need to settle for non-probability-based sampling techniques, which at least give you some information, but you will not be able to do, well, a whole lot of things with it. So I'm not going to go into too much detail, but there are advantages and disadvantages associated with probability and non-probability sampling. Just make sure that you are aware of them and see whether or not they are applicable to your study. Just some examples. So for non-probability, what we most often use is availability sampling. So you take a measure of the people that are currently available. So you administer your questionnaires to those that are there. You get their responses. You can also go for purposive or judgmental sampling, where you as the researcher will say, but I need to be very specific in terms of who am I going to target. And for the purposes of this study, I will choose X, Y, and Z. Okay, it's a little bit more specific than just say, well, I'm choosing people in general. So this PhD student that I'm assisting, he used to some extent purposive purposive and judgmental sampling. He looked at the subjective career experiences of employees from the designated group in the fast-moving consumer goods industry. So he had a very specific purpose and he only selected those industries. There could be others as well, but they had to be in those industries. Snowball sampling is, if you use it in qualitative research, it's usually when you ask someone, well, okay, can you tell me about someone else that may also be interested in this study? They tell you, yes, I think contact these people, it's a snowball effect, but not always useful. Then there's quota sampling. Please don't try and say, well, I want to get a representative sample of the South African population. Good luck. But then you can use quota sampling if you really want to go that route. Very important, the moment when you want to use probability-based sampling, meaning you want to randomly select people to participate in your study, you must have what we call a sampling frame. Anyone willing to tell me what is a sampling frame?
Representative of the whole population that you're going to study.
That's right. It's a complete list of everyone. So if you don't have a complete list of everyone in your population, technically you won't be able to randomly choose from that complete list. But just bear in mind, so with sampling, the whole idea is to say, well, okay, to what extent is my sample representative? Can I generalize my findings to the larger population? Not always possible. So please don't worry and say, well, for my study, I did not use probability-based sampling. It does not seem to be as representative as what I wanted it to be. You're not going to get a fail. Just be open. Just explain to the reader, why did you choose non-probability sampling? What are the advantages, disadvantages, and keep your conclusions within that particular framework. So with sampling, it's about getting a large proportion of individuals, providing you with answers to your research question. So in general, when you compare the more pragmatic versus the theoretical ideal, these surveys are the more pragmatic research design that you can follow, and the experimentation, the theoretically more appropriate one. Then yes, surveys will have less control, meaning less control of those other variables influencing what is happening. With experimentation, you can control for that. For brownie points in the methodology class, that's why we have random assignment. You want to create equivalent groups in terms of your control and experimental group, so that there are no other things influencing what you're trying to observe. Hence, you try and control for the influence of other variables through random assignment. I use that a lot at parties. In surveys, you've got fewer issues with external validity. So with external validity, the issue is, to what extent can I generalize, meaning do I have a large group of people whose responses we can treat as represented. With experimental research design, well, you may have a problem with external validity, because in experimental research designs you don't have such large samples participating in your control group and experimental group. So you may be up against some challenges there. For surveys, you've got more issues with internal validity, meaning if you observe a relationship, is that relationship only due to that one variable, or are there other things also influencing it? With experimentation, you control for that influence. So in a nutshell, yes, surveys are fine, but if you want to determine cause and effect relationships, go for experimentation. So, almost finished. Then I can tell you jokes about qualitative research. So we've looked at research questions and we've looked at research design. So just to quickly summarize, 4 kinds of research questions: description, explanation, prediction, intervention. We've looked at different research designs, more specifically true experimental research designs, quasi-experimental research designs, and survey research designs. Now let's spend some time with data analysis techniques. So in general, when we look at data analysis, we can focus on relationships. We can look at significance of group membership, and we can look at structure. So when we do data analysis and we're looking at relationships, then to some extent we look at bivariate R. So bivariate just means that there's a relationship between 2 variables. Multiple R, that's when we get with prediction. We would like to see multiple relationships predicting a particular outcome. That's relationships. Then significance of group membership. So you may be interested in saying, well, are there any significant differences between males and females in terms of their ability to use their hands again? Somebody you can also look at whether or not there are differences between those with degrees and non-degreed individuals in terms of their performance in the working environment. So the moment when you want to look for differences, then you can use some of those techniques, t-test. You can use discriminant analysis or analysis of variance. Not to go into too much detail, we use a t-test to test for differences between 2 groups. We use analysis of variance to test for differences amongst 3 or more groups simultaneously. Discriminant analysis is more about classification. It's something useful. Let's say, for example, you've got 2 groups and you would like to know, well, which combination of variables can correctly classify individuals either in terms of, let's say, success and not being successful. And discriminant analysis can identify those variables and tell you the percentage of success that you can expect if you use those variables to classify people into those 2 groups. If you are interested in structure, by the way, if you're in quantitative research, you must have structure. Then we can use techniques like factor analysis and structural equation modeling. We'll talk about that later during this. So, in general, data analysis techniques focus on relationships, group membership, and structure. So, how do you match them? Is there something else? I can go for an encore one. Okay. Thank you. Okay. So if your research design is description, what? Then what is the most appropriate research design? If you want to describe something in detail, meaning you want to describe relationships, you want to describe differences, then obviously you can go for survey research designs because you would like to get a large number of respondents that you can test for those relationships. You need a large group of respondents that you can use to test for differences. Yes, you can use quasi-experimental research designs to describe differences as well. But more often than not, you will use survey research designs. So if you want to describe something in detail, what are the more appropriate statistical techniques? Sorry, this is not pun intended. It is called descriptive statistics for descriptive purposes. So there you describe relationships. There you determine the frequency, meaning how many males, how many females. What is the average age of the respondent that participated in your study? What was the average recuperating time? Those kinds of things. You can use inferential statistics. Amongst other things, you can look at correlation. And then, depending on the purpose of your study, if you want to describe the characteristics of your measuring instrument, then this becomes very important. So let's say, for example, you are using an overseas measuring instrument in a South African context. You would like to know whether or not this thing is appropriate for South African conditions. Then you redo the reliability analysis and compare South African or your study's results with the reliability of the publisher's results. And if you would like to know the structure of that questioning, let's say, for example, you are measuring the big five, not in terms of wildlife, but in terms of personality characteristics. Yes, there's a big five. Or the five-factor model. Anyways, then you would like to know whether or not that factor structure is similar in a South African condition. So for descriptive purposes, you can describe the characteristics of your measuring instruments. And I will have a session on both exploratory and confirmatory factor analysis later. If your research question is explanation, then obviously you are not interested in just describing what, you would like to explain why this is happening. So, still survey research designs. Now quasi becomes a little bit more important, especially if you want to observe or to determine whether or not things have changed over time. You can still use descriptive statistics. Now you can use something called multiple regression analysis. Now this is your question that you asked earlier, to say, well, okay, are these predictors possible, or do they provide a possible explanation for the outcome that I'm observing? So we use multiple regression, or you can use structural equation modeling as well. The nice thing about structural equation modeling is you literally test the picture. So you draw your picture or your diagram, collect the data, and we test the accuracy of that picture. Unfortunately, I've removed that slide. That's really useful. So you explain why something is happening. Just to quickly give you this example, a student that's focusing on the subjective career success experiences, he's trying to explain how different variables can predict subjective career success. So he's looking at leadership, he's looking at a supportive organizational climate, he's looking at job resources, he's looking at psychological capital, and he's also looking at, what's the other one? But he's trying to explain how those variables work together to explain why would these employers experience subjective career success. So draw the picture. So a hop, skip, and a jump from explanation is prediction. So no real difference in terms of your research design or your appropriate statistical technique. So usually if you can explain why something is happening, you will be able to predict when it is going to happen. Just for some brownie points later on. With structured equation modeling, we've got two approaches. Technically, they say it's the variance and covariance, but they also call it the soft and the hard approach to structural equation modeling. The soft approach is variance-based, and the hard approach is covariance.